All right, welcome back. So today, we're going to pull back the curtain on some tech that you use, well, every single day, but probably never even think about. It's the absolute bedrock of our digital world, especially when things have to be fast and reliable. Let's dive in.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
You know, if you ask most people, they'd say Wi-Fi runs the world. And it totally feels that way, doesn't it? You're probably connected wirelessly right now. But is that really the whole story? Is everything important just floating through the air? Yeah, not even close. The truth is, in the professional world, we're talking offices where real business gets done, the massive data centers that are basically the engine of the internet, it's the good old-fashioned physical cable that's still king. And the language spoken over those cables, almost always, it's Ethernet. So to really get why Ethernet is such a big deal, we got to take a quick trip back in time. We need to see what early networks were like, and honestly, they were a total mess. Picture a chaotic one-lane road right at the peak of rush hour. That's what we were dealing with. And see, Ethernet isn't some brand new thing. It's a total veteran of the tech world. It popped up way back in 1980 and got its official rulebook in '83. But here's the wild part. The fundamental ideas from back then, they're pretty much the same ones we use today. We've just gotten a whole lot faster at doing it. So what was that digital traffic jam? In the networking world, we call it a collision domain. And the best way to think about it is like an old school party line on the telephone. If two people try to talk at the exact same moment, nobody hears anything. It's just noise. That was the reality for the first computer networks. And this shows you exactly what was going wrong. You've got two devices on the same network, and they both try to send data at the same time. Their electrical signals would literally smash into each other on the wire. The result? A garbled mess. The data was totally useless, and the communication just failed. Okay, so obviously this chaos couldn't go on forever. Networks needed some rules of the road, right? A system to manage all that traffic. And Ethernet came along with this incredibly elegant solution based on a principle we all learn as kids. Listen before you speak. Now, the official name is a total mouthful. Get ready. Carrier Sense Multiple Access with Collision Detection. Whew. We just call it CSMA/CD. But let's break that down. Carrier Sense simply means a device listens to the wire to check if anyone else is talking. Multiple access means, hey, lots of us are sharing this wire. And collision detection? Well, that's the backup plan for when two devices talk at once anyway. So how does this actually work? It's like a simple little dance. Step 1, a device listens for silence. Step 2, if the line's clear, it starts transmitting. Step 3, if it hears a collision, whoops, it stops talking immediately. And then here's the really clever bit. Both devices that collided wait a completely random amount of time before trying again. That randomness is the secret sauce, because it makes it super unlikely they'll crash into each other on the very next try. Okay, so we've solved the problem of when devices should talk. And full disclosure, modern networks with switches have pretty much made this whole collision thing a non-issue. But understanding CSMA/CD is still super important because it leads us to the next big question. How do devices know who to talk to? No, seriously, think about that for a second. In these early networks, every piece of data was basically shouted out to every single device connected to the wire. So how on earth did your computer know which data was actually for it and which stuff it should just ignore? It needed a name, a unique address. And that address, my friends, is the Media Access Control Address. You'll hear it called the MAC address. Think of it like a digital fingerprint. It's a globally unique number that's literally burned into the network hardware itself. In theory, no two network devices in the entire world should ever have the same MAC address. But here's the thing. A MAC address isn't just a long, random string of characters. It actually has a really smart structure, and that's what guarantees its uniqueness. So let's do a little digital anatomy and break it down. So at its core, a MAC address is a 48-bit number. Now, to stop our human brains from melting, we write it out as 6 groups of 2 hexadecimal characters. You know, the numbers 0 through 9 plus the letters A through F. Each of those pairs is called an octet. So a 48-bit number, what does that actually get us? How many unique addresses is that? It's over 281 times trillion. I'm going to say that again. Trillion with a T.
That is such a ridiculously huge number that it's what allows us to be pretty darn sure no two devices will ever accidentally get the same address. And like I said, it's not just one big number. The MAC address is brilliantly split right down the middle into two parts. The first half tells you who made the device, and the second half is a unique serial number that the manufacturer assigned to it. Simple as that. Let's look a little closer. The first 3 octets, that's what we call the Organizationally Unique Identifier, or OUI. A big standards body, the IEEE, hands these out to hardware makers. You know, your Intels, your Apples, your Dells. Then, the manufacturer takes that OUI and uses the last 3 octets to create a totally unique ID for every single network card they produce.
All right, so we've gone through collision domains, CSMA CD, unique addresses. You might be thinking, okay, that's cool, but why does this actually matter? Well, it matters because this is the difference between just guessing what's wrong with a network and actually knowing how to fix it.
For anyone working in IT or even just curious about it, this is the foundation. It means you can look at a cryptic MAC address and go, ah, that's a Cisco device, or that's an Apple laptop. When something's not connecting, you're not just restarting the router and hoping for the best. You can actually trace the data's path and see exactly where things are breaking down. And that really is the key takeaway here. This isn't just some abstract theory or trivia. Understanding how Ethernet and MAC addresses work on this fundamental level is a critical skill. It's what empowers you to diagnose and solve real-world network problems with precision and, frankly, a lot more confidence. So the next time you plug in one of those blue Ethernet cables, take a second to remember the incredibly elegant dance that's happening hundreds of times a second, all based on a set of rules dreamed up decades ago. It really makes you wonder, right? What other invisible tech is quietly running our world behind the scenes? Thanks so much for joining me.